This is All Things Ansys, a podcast from the technical support staff at PADT. Episode 126, the All Things Ansys podcast returns with a talk about Ansys Mechanical 2024 R1 and news and events from around the world of Ansys. Well, hey there. I'm Eric Miller, your very guilty host of the All Things Ansys podcast, one of the owners here at PDT, and someone who has been struggling with procrastination lately. Let me start by apologizing to our regular listeners. We did our last episode in December, and I thought, wow, I'm busy. Maybe I'll do the next one in February. Just skip January. Well, in February, I have work and vacation. A lot of work and a lot of vacation. So March rolls around and, well, you get the story. We did record our interview for this episode in March, and I just never got around to recording the rest of it. So here we are in April. Hopefully you enjoy it, and hopefully you will continue to listen. A lot has happened in the world of Ansys during that time, so we'll cover some of that after the interview. I do also want to mention to you a little bit of an excuse for why February was so busy. It's not Ansys related, but I suspect it is of interest to so many Ansys users. I was lucky enough to go with a friend of mine on my fourth Star Trek cruise. Yes, you heard me right, Star Trek. I've been a fan since I discovered the original series reruns on after-school TV when I think I was in third grade in the early 70s or mid 70s. And I've been a big fan ever since, through every series and most of the movies. I can say that Gene Roddenberry is one of the people that really had a big impact on my life, and the vision he created on that screen inspired me for my whole life, and it still does today. That is why I enjoyed the cruise so much. It's nothing but a boat full of Star Trek fans and a small number of Star Trek actors. I've never spent time around a more diverse and accepting group of people. We do Star Trek things, and we listen to Star Trek actors, and we do have lectures from Star Trek experts and things, but just like a convention. But we also meet new friends and reconnect with old ones, including some Ansys users I met on the cruise, and even an Abacus user, boo hiss, but I was still nice to him because we are accepting in the world of Star Trek. So good fun. Anyhow, whatever your fandom is, I guess that's my point. Whatever your fandom is, embrace it. It's good for the soul, and live long and prosper. So on to our interview. Time marches on, and we have a new version of Ansys products, 2024 R1. It's been out for a little bit now, and we are starting off our discussion on what's new in 2024 R1 with Ansys Mechanical. I'm joined by two of our expert engineers, Peters and Joe Woodward, and let's go ahead and see what is important and exciting in this new release. Welcome to everybody. It's been a little while since we took a little bit of a break from the podcast, but we're back again in one of our discussions about what's new in different parts of the Ansys software suite. And today we're talking about, my bread and butter, what I learned, Ansys Mechanical, and we're up to 2024 R1. And I'm joined today by Jim and Joe. So Jim, why don't you introduce yourself, what you do here at PDT, and then Joe, same thing.
Yeah, I'm Jim Peters. I'm the Chief Engineer of Simulation here at PADT. So my primary role is consulting services using the Ansys products, and then also help out with tech support, training and mentoring on the support side. So,
Joe. And I'm Joe Woodward, Chief Engineer of Simulation Support. So I help out with support and training, and then help out on the services side once in a while. It's been a while, though.
It's been a while. Yeah. So we're here to talk about Ansys 2024 R1, like I said, Mechanical 2024 R1, which is, the flagship product, the names company. It's a fairly robust release. So, Jim, I'll just kind of let you take us down some of the things that you think that users should know about, what's got you excited, what is kind of important about this release, because I know there's a lot of stuff under the hood, a lot of little things, but I don't know if there's anything major to discuss as well.
Yeah, well, certainly, each release, as more and more products get integrated, there's quite a plethora of capabilities and things coming in. So there's at a top level,
Mhm.
there's a lot of focus on trying to fully support kind of the automotive and
Right.
noise, harshness, and vibration area.
Uh-huh.
So there's a lot of new capability coming in the area of acoustics and meshing and things in support of automotive sector and related technologies to that would take advantage of those kind of workflows. And then of course there's always feature function enhancements and
Mhm.
so forth associated with different aspects of the code, and certainly meshing is one that is highlighted in this latest release as well. There's a couple new mesher capabilities under the hood in addition to just enhancements of the current capabilities. So that's certainly an area of work. And then again, there's just a lot of enhancement and support related to products that use the workbench environment
Mhm.
as its
Okay.
base. So it's a kind of a nice list of things.
Yeah, because a couple things I want to go back to on that. So the first one is, this NVH stuff is kind of important and gets into also some capabilities for flight vehicles and space vehicles as well. In that, um, your company, listeners, may still have some copies of that other piece of software laying around. And one of the reasons why you may still have copies of that other piece of software laying around is to do NVH and some of this more advanced acoustics and modal stuff. Rest assured, ANSYS is working really hard to add that capability to the code, and it sounds like that this release has got some nice enhancements. So if you haven't checked it out in a while, do check that out, because I think and meshing as well, right? You may be using a third-party mesher because you're working with that kind of geometry, metal frames with metal stretched on the outside. Great tools now coming along for those things. Um, the other thing is this idea of ANSYS Mechanical as a platform, right? So it's not just creating a model to solve mechanical APDL anymore. So there's a lot, right? I mean, you use it quite a bit for LS Dyna, right, Jim?
Yeah, that's right.
Hmm.
Yeah,
Yeah.
and that's just one of the applications
Yeah.
where there's more exposure to capabilities within Alstina
Hmm.
supported within the workbench environment.
Great.
Yeah, there's quite a few updates on that front, right?
Hmm.
Yeah, definitely a
Yeah.
lot of those.
Yeah. How's
Yeah,
the post processing coming for LS Dyna in mechanical?
yeah, it's getting more complete. A lot
Okay.
more of the a lot of Alstina post processing revolves around getting result sets and plotting them as a
Hmm.
function of time and so forth. So there's a lot more support for some of the common, um, ASCII and binary forms of the time history data.
Okay.
So,
Good.
and some of the charting and so forth allows you to combine some of those quantities together to get, a more inclusive overview
Hmm.
of what's going on there.
That's good to hear, because those of us that grew up on LS Dyna Post might be fine with it, but I would imagine that it's still a pretty steep learning curve. So using mechanical is probably better.
Yeah,
Good.
certainly helps there. And other products as well.
Mhm.
The interface for ANSYS Motion
Good.
is continually being enhanced.
Hmm.
And again, just the general marrying of different capabilities and the automated workflows is really what's kind of the upper theme of a
Okay.
lot of the development is making sure that at different types of analyses and technologies that can be used together all have communication links to be able to
Hmm.
exchange information.
Okay. Good. More of the that's really good to hear. So you kind of touched on meshing a little bit, and we may go into more detail in a separate call, but have there been any big changes in meshing in this latest release, or is it just enhancements across the board to support more better?
Well, a couple of the new meshers, of course, the stacker meshers, which is used for kind of PCB and
Right.
extruding in a single direction, that was kind of introduced in late in the 2023 series, but continues to be enhanced there. There's a Prime Mesh is another mesher that's kind of designed for shell-based structures.
Okay.
So it's a shell mesher. Overall, tries to generate a much better quality mesh on very large, more complex topology.
Good.
It's like that, and it's kind of built in to work with the the welding capability, doing the both intermediate and continuous seam welds and so forth with 2D representations. So
Like that. Okay.
yeah, so there's been a lot in that area, and then in the three-dimensional world, especially on the explicit side, there's some new capabilities to be able to kind of tweak and move nodes in meshes to try to obtain a better quality elements. On the Ellis-Dyna side, it's very sensitive to mesh distortion and so forth. And if things get too short of an edge, you get really small time steps, and solutions can kind of get out of control. And it has some new options to be able to morph those nodes to improve that capability, either keeping them on the surface or allowing them to be redistributed within the volume to try to handle areas of really complex transition, like really sharp edges of cylinder engagements and things like that, where just adjustment of the node a little bit would improve the time step immensely. Right. So there's some capabilities to kind of try to automate and do that without having to do full remeshes.
Very cool. That could be a day saver, actually. Yeah, I remember doing that manually. Good. Yeah.
There's also a lot of updates to the multi-zone.
Okay.
Looks just in their internal algorithms trying to get better patterns that sweep as it's sweeping through. Okay. Just overall general improvements along the way.
So better, easier hex meshing.
Yeah. A couple of the algorithms that I really jumped on, again, late in the 2023 series, and it's been enhanced even farther in 2024, is the thin mesh capability of the multi-zone solver. That's an algorithm that's there to handle thin structures or relatively thin structures, and it has the option to be able to use full solids or solid shells. And so good. That's a huge one. That was one of the subjects of the blog I put together for the exposing of the thick shell and Ellis-Dyna in that environment. So that particular algorithm is much more robust than the sweep method that used to be the only method of getting solid shells. So there's some really nice enhancements that way.
So, one area that we haven't really touched on in quite some time in the podcast, because I guess, it's not having a problem, so no noise, is materials. Any changes to the material side of things in Ansys Mechanical, or is that pretty much kind of just small tweaks here and there as time goes by?
Yeah, no, there's actually pretty major changes.
Okay.
A lot of material models, a lot of new capabilities of adding more complex material behavior to existing material models has been added in the last few releases and continues today. There's some new more enhanced materials being introduced into the mechanical environment in 2024, and just in general, trying to come up with a very consistent definition across all types of physics for being able to model highly nonlinear materials and so forth.
Mhm.
So.
Good. Yeah, because we used to have to kind of code that in, right? And now it seems like they're exposing more and more of that. That's good to hear. It's good to hear.
Yeah.
Good.
It seems like a lot of the material stuff, it's a little note here, and for the people that use that, it's a huge it's a huge improvement.
Okay. Good. Good. So check it out. If you're doing it the old way, definitely learn it. Good, good, good. Let
One
me
thing
think what else. Go ahead,
I'll
please.
point out is the new kind of switch on the contacts.
Okay.
The default contact formulation for bonded contacts is now MPC,
Oh.
which so helps. It says it offers better convergence
Mhm.
and helps non-rigid body mode issues that had come up in the past with the augmented Lagrange formulation. So they've switched the default. So that's one of the things we try to watch for
Mhm.
when we get customers that say, okay, so we have an old model, it's not behaving the same as the new model.
That's a big
What's
switch.
different?
Yeah.
Yeah, what changed in the last 7 versions type of thing.
Yeah.
That's a major switch. So just be aware of that.
Yeah, that's definitely one area where existing models and so forth will behave, potentially significantly different with that particular change. So that has been a topic of positive response and some negative response. And so I think I did see the latest list where there has been a script written to be able to reset it all back to the
Okay.
prior settings if you really want to.
If you really need to, yeah, to get that
Yeah,
same
just
result.
just for consistency
Yeah.
between releases. So
It's
Yeah.
probably a more efficient, the new way of doing it, but you may want to repeat to compare apples to apples. Gotcha.
Right. Yeah, they probably want to run it in the older one with the MPC and
Mhm.
compare it both ways.
Yeah.
yeah. Part of the features associated with some enhancements are related to the MPC and being able to provide some mechanism of preventing over constraints. The MPC formulation is one that you have to be really careful about the proximity of overlapping contacts. You can get a lot of over constraints developed with that algorithm. And so there are some new automated features to go in there and try to figure out and identify when you have over constraints. And one of
Oh.
the new information on the contact tool is whether or not that particular contact has potential of having over constraints associated with it. So that's some good information which wasn't intuitive to be able to figure out previously. There's now a column of information that can kind of track that, and so that's a really nice enhancement to help with that.
I'll say.
Yeah, I'm not sure they could have just switched it otherwise.
Yeah, definitely. Still have to be sure you're understanding how everything's set up, but diagnosis of problematic models and so forth is always, it's helpful to get new tools to be able to understand what's going on under the hood.
Yeah.
So,
That could save, again, another big time saver. So, what about, other pre-processing areas like boundary conditions and loads and things like that? Any big changes there?
yeah, Joe, you want to go ahead or? Yes.
I was gonna say that they're always adding
Yeah.
to the multi-stage cyclic,
Okay.
adding to the capabilities there,
Mhm.
the loading and things that it'll handle.
Mhm.
Um, I'm scanning through some things right now to give some examples. One of the things, adding in pressures that maybe hadn't been there before.
Okay.
Um, So that was always one thing. You had to have all your loads in the model, even if they were zeros.
Right.
Now you can add a direct pressure load as a later restart, and have it. Basically it assumes that it was zero up to that point, and then it adds in. So I'm expecting in the next few reversions that they're going to continue to add different loads to that, but they started out with pressures, and they'll go from there.
Most common, yeah.
Okay. And of course, fractures another area where there's
continue to work.
Continues to be more and more capabilities there, combining different types of cracks, edge cracks, and
corner through.
Yeah, a lot of new capability there, and that coupling it with the cohesive, elements as well as another mechanism to study progressive fracture. So again, trying to tie together some other capabilities that were kind of always there, but kind of combining them together to get a little bit better approach to modeling those type of situations.
Yeah, that's good. That's really impressive. And then maybe we'll finish up with any solver changes, or I guess it's really controlling the solver, right? We'll come back and talk about maybe a solver in a separate one, but anything on the solver side of things to bring up?
There's definitely been, of course, they're always optimizing it.
Yes.
They've quoted the latest as running a 1 billion degree of freedom model with HPC. So,
wow.
In terms of the probably the most visible changes is enhancement to the PCG iterative solver. Oftentimes you're forced to having to run the direct solver, but when you get into really large models, it is very memory intensive. And sometimes you just, even with a lot of memory, you run out of memory with the direct solver. I've had some consulting projects where I've had to use that iterative solver for extracting, 250 modes on a really large model. And that was the only way to actually run
Put it in there. Yeah.
Even exceeding the 1 terabyte of RAM on our biggest machine still was kind of reaching that limit for this size model. So that one really, I think in terms of the being able to optimize your equipment and so forth, that's kind of a big change with the PCG becoming more functional in more situations.
Okay, good.
Yeah.
That is a big deal. Yeah, okay. Anything you guys want to bring up that we haven't talked about?
So there's the new themes.
Okay.
Basically change your change the way the screen looks. They have the dark theme and the light theme, and that always makes me laugh. But
well, I remember the fight about changing when they originally changed the color. So the fact that people can do their own now is good. Good.
Right, exactly. Yeah. people will either love it one way or hate it another way.
Little thing that makes a difference. Yep.
Yeah.
That's good to know.
Well, probably the last thing would just be there's some very specific workflows for NVH involving acoustics. And so there's, the ability to be able to use both FEA and BEM type acoustic solvers is really what's being introduced in the 2024 series is exposing the BEM acoustic solver out of Elestina into use within the mechanical environment.
That was my next question, is where did that come from? Because we've been after that for quite some time. Is by any chance electrostatics available yet, or?
That's some of the other capabilities coming in there. And again, a lot of these automated workflows is just handling the transition meshes for the boundary of the acoustic domains and so forth. So a lot of those, the manual processes can be somewhat tedious, and these have been set up to make that a little more automated. So
Cool.
Definitely a nice area for that application space.
So a lot of these more difficult and complicated simulations that we kind of sighed before we dived into are getting easier with these workflows. So that's really, really positive. Yeah, fantastic. So what's the best way these days to learn about these new enhancements? Is it still the release guide or the new release documentation, or what's your recommendation?
Well, the
First thing I always do is go to mechanical and the project branch and go to the worksheet and kind of scroll through those to start with. They'll usually
just
have
see what's there.
They'll point you to more detailed documents on them.
Yeah. The latest 2 releases have kind of offered that overview kind of in the worksheet environment.
Excellent.
Right?
Okay.
Launched it, so you can kind of get a feel for that. And then some of the ribbon tabs have been, redone and reorganized again to be able to have direct access to, documentation sources and so forth as well. So a lot of those are being enhanced in terms of being able to find the documentation for those particular features a little easier.
And then is the Learning Hub caught up on these new features? So if you want to dig in deeply to one of them, they're in there.
Yeah, there's a link to accessing the Learning Hub through that ribbon tab too.
Okay.
Obviously,
Excellent.
I've got the subscription, but at least there's linking to the sources there. So.
And of course, if you are a PADT customer, you can definitely reach out to our team and ask questions to us, and we'd love to help you. Really positive.
Our seminar series is going on now too. So I think we've had the part 1. There's 2 more parts to the 2024 summary, and then I'll be doing the Ellis Dyna one a little bit later in the year as well to get enhancements related to that particular product as well. So certainly a lot of avenues.
I'll be running one on Discovery.
Okay,
good. I believe in April. So
that's a fast-moving target as well. There's a lot going on there. Yeah.
Right.
Oh my gosh. I hardly recognize it. So that's cool. All right. Well, I always really appreciate it, and I need to get off my rear end and shut down all the HR screens and get back in there and learn some of this new stuff. I'm falling behind fast. But thanks always for taking the time to help us understand these things, and we look forward to learning more of other things. And then we definitely check out our webinars, and I'll talk about that after the one in the rest of the podcast. But we got webinars coming up to go kind of dive deeper into all these things, which everybody is welcome to watch live or recorded. So thanks, guys. You have a good rest of the Tuesday, and we'll talk soon.
Thank you. You too.
Good.
Bye.
All right.
Bye.
Take care. Bye now.
Okay, I'll be honest. Part of me kind of wants a release where there isn't much new, just some bug fixes and stuff, so we can skip, say, hey, we can skip this one. But nope. The Ansys development team around the world is listening to you as users. They're adding new capability and making existing capabilities even more efficient, making better workflows. It's just they continue to just really work on this code. It never does seem to slow down, which is a little bit of work for us, but as much as we complain, we really do like it. So it's been a while since we talked about PADT as a company. So let's do that for this episode's commercial, especially since, as you will shortly learn, we are celebrating a very important milestone. So PADT is a 95-person company based in Tempe, Arizona, with offices across the Southwest that is the leading provider of products and services to companies that design and manufacture physical products. We started the company back in 1994. And our 30th anniversary was just 2 weeks ago. So yeah, it's been 30 years since we incorporated the company. We took 3 core computer-aided engineering technologies that we were using at a company called Allied Signal Engines. We were making turbine engines. It then became Honeywell Aerospace, what it's called now. And we built a consulting company around them. We did simulation, advanced design, and what we now call 3D printing. A few years in, the vendors who were providing us with the tools and asked us to become a reseller, including Ansys. And that is how we became an Ansys channel partner and started selling Stratasys equipment. Later on, we added Flonex for 1D thermal fluid systems, EOS for metal 3D printers, and the combined Zeiss GOM company, which goes under the moniker of #hands-on metrology. Not a great title, for optical and laser scanners. We continued to provide services with teams dedicated to product development, simulation, and 3D printing, those same core things we started the company with, as a service to our customers. So really, if you're developing a product in any industry, PADT can help in some way by helping provide the tools you need, training and support on those tools, or services for simulation, design, and additive manufacturing. So you can learn a lot more about PADT at www.padtinc.com. Most of you know us for Ansys, but we do a lot more. So please do consider talking to us about the other things we do, as well as helping you with your Ansys. All right, let's move on to news. Well, one thing happened at the end of right after we did the last, maybe it was just before we did the last episode in December, or maybe it was just after, rumors started leaking that something big was happening, that somebody was looking to buy Ansys. Well, those rumors were true. Synopsys in mid-January officially announced that they were in the negotiations to acquire the company Ansys Inc. If you didn't look at the details at the time, or as a reminder, because it's been a little while, here are the 5 takeaways that were in all the press releases, and I think this kind of gives you, at least a public version of why they're doing this. So it combines leaders in semiconductor design technology and simulation and analysis. So, Synopsys is focused on the semiconductor part, and Ansys has a huge semiconductor business as well. And the goal is to address customer needs for the fusion of electronics and physics, augmented with the up-and-coming AI technologies that both companies are investing heavily in. It enhances and accelerates Synopsys' silicon to system strategy in the core EDA. That's I think that stands for electronic design and analysis, and new attractive adjacent growth areas. So that's the rest of the Ansys world that Synopsys doesn't really sell into right now. So it expands their total addressable market. Speaking of which, that total addressable market, the TAM, by 1.5 times to $28 billion. And that is growing they're predicting an 11% growth year over year. So they feel together they'll deliver a high growth, high margin, recurring revenue business, expected to expand the non-standard accounting calculation of operating margins by 125 basis points, and unlevered FCF margins by 75 basis points. I don't know what an FCF margin is in the first full year post-closing. So those are important to Wall Street people, I think. The other thing they said is they expect it to be accretive to the earnings per share within the second full year post-close. So after they've done all the cost of merging the two companies together. And then they expect that to accelerate to be what they saw substantially accretive thereafter. So the deal is around $35 billion to buy the Ansys company. So if you've been around as long as I have, and when you remember it was just a handful of people and maybe selling $100 million worth of software a year, maybe less than that when I first started. Yeah, that's quite an accomplishment. So, whatever happens with this, kudos to everybody that's worked at Ansys over the decades that's gotten this to be a company worth $35 billion. So that's pretty incredible. So you're probably asking, how has this impacted, resellers like PADT, Ansys users like you? And the answer is so far not a bit. Nothing's changed on our end. In fact, we're doing our quarterly review from a sales standpoint right now. Nothing's changed there. We've given no direction on what the post-acquisition company will look like. These things are all against the law, right? They got to really focus on doing business the way they normally do until after the acquisition. So I think it's really good. It hasn't really impacted us at all. So my personal opinion, and this is mine, nobody else's. I have no insider information. Nobody said anything to me. In fact, nobody's saying anything about this. But my opinion is that this is not a competitive situation where Synopsys is looking at Ansys as a competitor and wants to take them out of the market. This is additive, or they call it accretive, right? So this is additional revenue for them. So my hope is it'll result in more spending on R&D, more interconnection between more physics and more products, more investment in AI and other new technologies, and more physics for us to simulate. So I think in the long run, it's going to be really, really good. And we won't know what's going to happen until it happens. There's not much else I can say because, like I said, we don't know anything. But stay tuned. As things become public, we'll summarize it and share it here and try and look at it from the perspective of users. But so far, no change. An important detail on that is that they don't even expect the deal to take place until the first half of 2025. Probably won't impact users or any changes to how things are done till the end of that year. So, we're really looking a couple years out before we start seeing any changes. So anyway, so this is usually where we look at the stock price. So let's do that. Synopsys was, at the time of the announcement, offering in their press release, they said they were going to offer $390.19 per share. And that was going to be $197 in cash and then the balance in Synopsys shares. So people who own Ansys shares will get a little bit of money and then they'll get shares in the new company, the combined company. So when the rumor started, the price went up from $294 to $362. So that rumor just shot the price up. And then it kind of sat there because it obviously was a valid rumor. And we're now sitting at $346. So if you remember, the offer was at $390. So it's not even as high as the offer right now, which I don't quite get. Why isn't it? I don't understand Wall Street. There's not much else to say about that, right? It's not going to fluctuate a lot. We're not going to see the drivers that we usually see that affect the stock price. It's pretty much people either betting on the acquisition happening or not happening, right? By the way, Synopsys is at 578 today. They were at 494 before the acquisition was announced. So that's a 17% jump. Now the market in general has gone up quite a bit. So some part of it's that, part of it's the acquisition. So we'll watch that, but not as closely as we used to. Stock price is going to be a little biased right now with this. So other Ansys news, because that's kind of big Ansys news, and does the rest of it even matter? I don't know. The really big news that I think hopefully all of you saw, because it was all over the place, was this fantastic announcement of a cooperation between Ansys and NVIDIA around mid-March at the big NVIDIA conference. And it was a surprise how big it was actually to everybody I knew that was there from Ansys. They were all very pleased to see the commitment that NVIDIA is making to Ansys in the long run as a partner, because as we saw when the NVIDIA chips were being used for Bitcoin mining, eventually people went and made custom chips, right? And the same thing will probably happen with AI. And NVIDIA will, of course, try to be one of the companies making those AI systems. But Ansys is always going to need a platform that they can run different math on, right? And that's what the GPUs do great at. And we're just seeing more and more stuff. Same with our AI and everything. So expect to see great things coming out of that relationship and even more horsepower in the hands of you, the users. Really exciting to see. Really, really excited about that. The other thing that they announced between the last time and now was their annual results, right? Which is usually a kind of a big deal and it affects the stock price and we all really care about it. But with the acquisition pending, it's good news, but it's not as big of a news as it used to be. So here's the highlights for the 2023 year. I'm not going to look at Q4. Let's talk about 2023. So revenue was $2.27 billion. That's a 9.9% growth on revenue. Profit was $500 million, which was a small drop of 4.4%. The profit margin was 27.6% using standard accounting methods. And if you don't take into account, when you basically pay for expenses and things is what changes between GAAP and non-GAAP, standard and non-standard. So the way they like to count it internally, it was 42.6%. So nice growth in profit margin. And they had a $717 million cash flow, so positive cash flow. What else to look at? I like to look at where the money is coming from. So if we break it down by percentages, 34.5% of the Ansys revenue in 2023 was lease revenue. 13.3% was perpetual. So that's quite a change over the years, right? It used to be a lot more even between those two, but more and more people are leasing their software. There is 48.6%, getting close to 50% of the revenue comes from maintenance, which is fantastic. That nice run rate. And only 3.4% was services, because as you know, they don't do a ton of services. So where was it coming from around the world? Well, just under 50% at 48.7% was from the Americas, both North and South. And then in the other two regions, it's funny, they break it out by the number one country and then the remainder. So the biggest country for them in Europe, the Middle East, and Africa was 8.8% of the total revenue from Germany and 17.9% from the rest of Europe, the Middle East, and Africa. And then in Asia, it was 8.9% from Japan and 15.6% from the rest of Asia. And for those of us in the channel, we care about this. You guys probably don't, but 73.9% was from direct sales and 26.1% was indirect. And what they mean by indirect is companies like PADT that work more closely with customers and provide first-line tech support around the world. So it's not as important now as it used to be back in the past, but they have $860 million in cash, which is a big jump. That's up from $615 at the end of last year. So that cash flow that we talked about a little bit earlier, that $717 million, they kept a lot of that and were able to really get their cash reserves up, which in the past I'd be really excited about because it means they get to buy somebody again. But we'll see what happens with that. And if they, I don't know if they can buy somebody before the acquisition. I'd have to ask somebody that knows the law around that. Anyway, good stuff. Good year, strong end of the year, especially with some of the turmoil in the markets these days. So really, really happy to see that. Yeah, that's pretty much it. I'm going to skip going over Ansys blog posts that I recommend. You guys can take a look at the Ansys blog and see for yourself. There's been a lot of really good ones, too many to really pick from, and we've been going a little long. So let's just move ahead to the PADT blog. And we've been busy there as well. People are just publishing. So I'm just going to bring it up right here on my screen and talk about some of the cool things that our experts here at PADT have published blog articles on. And we'll look at the first one right after the last podcast, which was called Ansys Electronics Desktop Parameterized Materials. So if you're using AED for any of the electronics products and electromagnetics products, this is a really good article from Tyler Bunton on how to parameterize your materials, which is really important to do these studies that we like to do. We also have one from Alex Grishin that is a real in-depth look at something called geometric singularities and finite element problems. So take a look at the article. You'll understand why that's important. But the short of it is that the way that we solve for this element, right? And we solve our points in the element. If you move the points to a certain place in the element, it comes to one of those divide by zero things, and the results blow up. So this is really a look at a lot of younger engineers or even older engineers that forgot. Don't pay attention to this, and you can get really kind of maybe not blow up to infinity, but you can get some high stresses that aren't realistic because of the distortion in your mesh. So this kind of explains the math behind that, as Alex is really good at. He also did a really good blog post more on PyAnsys. So this one looks at using Python and PyAnsys to do data mapping in Ansys Mechanical. So you want to take data from like a big model. Say his example is he's got a nose cone and he's got some results from that, and he wants to map it on a printed circuit board in the nose cone. And he shows how to do that using both Python in Mechanical and PyAnsys outside of Ansys Mechanical. Really important article. I think that it's really good for people that are interested in that topic. Take a look at that. And then I'm going to go take a look at what else we published. Excuse me while I click here. The next really good one was on installing Ansys SCADE 2024 R1. If you've not used it, it's a tool that does embedded systems programming and simulation. And our expert in that area, Noah Asherbrenner, he did a really cool article about how to install it. And it's really important because, right, it's a tool that works with your control software, right? So it's not just like turn it on, right? There's a bit of it to it, and he really helps explain how that works. There's also an article from Jim Peters where he's looking at the new LS9 thick shell element. We kind of talked about this in the interview today, with the Ansys LS9 thick shell element in Ansys Mechanical. So you can set up these thick shells. You've been able to do that for a while for solving in Mechanical Solver, the Mechanical APDL solver, but now you can use it with the LS Dyna solver, which is very handy. And the article goes into why that's so important. So if you're using LS Dyna, I highly recommend that. Then Alex Moody, our high-frequency electromagnetics expert, takes a look at dealing with Ansys HPC. So speaking of GPUs, we've covered this topic before, and I think we need to continue to cover it because we get a lot of support calls on, well, how many licenses do I need to do this? Or, how do I count GPUs versus CPUs versus cores? So Alex does a really good job at looking at that. So check out that article from mid-February. Like I said, there was a lot. I warned you. Then Tyler comes back with some more about the Ansys electronic desktop, and this time he's talking about something called an Amperian loop. So if your ears pricked up on that, you're interested in it, and it's a cool thing. So we recommend you check that out. So Ansys electronic desktop, Amperian loops from the beginning of March. And then I published the fact that we republished the trusty Ansys APDL Get Summary Sheet. So those of you that have been around the Ansys world for a while and know PADT from back in the old days, we used to hand these out when we used to do user group meetings in person, both regional and national and international. And if you use APDL, you know that StarGet is one of the most powerful ways to access the data in your results file and in your model database, your .db and your .rst/rth files. And that's how you pull data from them, right? And you can do amazing things with StarGet and then use that data to change your model and do all sorts of cool stuff. But there's a lot of commands. There's a ton of StarGet commands. So we, Rod Scholl, who used to work for us and now has his own company, came up with this years and years ago. He's also the guy that originated the newsletter that became our blog over the years. And really handy little tool to look that up. So if you're still using APDL and you missed that sheet or you didn't know it existed, go check out that blog post and download it. It's actually kind of cool and a little bit of a walk down memory lane for some of us. So really enjoyed that. So what is next? So that's, like I said, we had a lot of blogs and I've actually got 2 more I'm going to publish this week or next. So stay tuned for more there. Webinars, that's right. So we've got a ton of webinars coming up as well. In the world of simulation, we're going to focus on a couple of things. April 10th is where we're going to do our update on discovery in 2024 R1. And then on April 24th, we're going to do our structures update where we're going to talk about fracture, linear and nonlinear dynamics. So we're going to talk about those 2 things, fractures and linear and nonlinear dynamics in 2024 R1. And then on May 8th, we're going to talk about fluid material processing updates in 2024 R1. And that's going to be it for our seminars, for our webinars for that time of year. And then we are really going to do some events, right? So we've got a bunch of events coming up. I'm going to be at the Space Symposium along with some of our other Ansys folks. So if you're going to the Space Symposium in Colorado Springs this year, April 8th through 11th, I'll be in the Arizona Space Industry booth. The rest of our team will be wandering around or in the Ansys or Stratasys booth. So if you see somebody in a PADT shirt, make sure you say hi and you listen to the podcast. And like I said, I'm going to be in the Arizona Space Industry booth. So stop by and say hi to me if you're there. Also, if you're interested in additive manufacturing, 3D printing, we're going to be doing the tour truck again with Stratasys. This is where they take all their latest machines and put it in a truck and drive it around the country so you can actually see the latest machines. And we're going to be in Houston on April 22nd, and Dallas April 24th. And then May 7th is going to be Albuquerque, and May 9th is going to be Los Alamos. So look for that in your email or check out our website to sign up for that. And then Ansys has a big event that you don't want to miss in May, which is their annual Simulation World 2024. If you've never attended before, it's an online conference, so you can work while listening. It's usually half days. It's the 14th, 15th, and 16th of May. So do plan on signing up for that and attending, and sign up from our website because we get credit if you sign up from our website. So we do appreciate that. Like I said, we had a lot. So a lot of catching up to do there. If I skip 3 months, that's what happens. So I want to thank everybody for their patience and understanding with us taking a little break there. Don't forget to subscribe to our newsletter at www.padtinc.com/opt-in. That's where you get all the latest news as soon as it comes out. And we do that one every month. Do spread the word. Let people know about the podcast. Make sure you subscribe and that they subscribe. And as always, don't hesitate to reach out. Thank thank you for joining us for the All Things Ansys podcast, episode 126. As a reminder, this podcast is not affiliated in any way with Ansys Inc. or anybody that's trying to buy them, and the opinions expressed are those of the people on the show only and not of their current or former employers. For more information, visit www.padtinc.com/blog, and please share your thoughts and questions through an email to podcast@padtinc.com. And see you next time, hopefully sooner.